In this webinar, we are going to target some of the basic lessons that we have learned on building effective cloud architectures. This presentation is targeted at architects who are trying to build cloud architectures in the AWS cloud, and I'm going to talk about some basic best practices. Unfortunately, there is no one panacea architecture that one to rule them all, because it really depends on what you are trying to build, what is the goal of the use case, whether it is the cost effectiveness, whether it's speed, whether it's high availability and mission criticalness, and so forth, or depending upon what you're trying to get out of your application architecture. So basically, from an architect perspective, it's important to understand that it is understanding the trade-offs and then mastering them. With this basic thought in mind, I wanted to bring this up very early and go into the basic details about learning how to build cloud architectures. All the things about this particular webinar is also available in a white paper format. It's available with all the different concepts, best practices, tenets, patterns that you can you need to be aware of when you are building cloud architectures. One thing to note here is that this particular document is a living document. We are going to continuously update this document with the latest stuff that comes along, the things that we learn, the new best practices that emerge from our customers as well. So I highly recommend reading this best practices document, and it also contains a lot of simple tips and tactics for individual concepts. So I highly recommend passing it on to other friends and colleagues who would want to learn about cloud architectures. So let me talk about briefly the technical benefits of the cloud, and I assume that most of you might already know about the cloud, and this particular 5 things which I feel are important from an architect perspective to understand and sort of make it an intrinsic part of the application architecture design. And these are some of the things that I like from an architect perspective about the cloud. The first thing is abstract resources. Cloud gives you this conceptually infinite access to all these resources, but these resources are really abstract in nature. You're not dealing with servers, you're not dealing with hard drives, you are dealing with instances and volumes, and these resources are fungible. You need to understand that you can, if one fails, you can quickly get another one and replace the old one to the new one, and then keep going. So that's fundamental to the architecture principles. The second important thing is that cloud provides on-demand provisioning, and so you can get as much as you want when exactly you need it, and then get rid of it when you exactly don't need it. So it's important when you combine these abstract resources with the on-demand provisioning model, you get this much more powerful paradigm to work with when it comes to cloud. Now, the third thing, which is around scalability, is happening within minutes. Previously, in the past, in the pre-cloud era, it used to take 4 or 5 or 7, 8 months to actually get a server in place. Now, scalability is actually happening in minutes, and this actually does change how you build and design your architectures. For example, if you are spending 2 days in installing and configuring a particular server, that does need to change in the case of a cloud, because you are getting machine within minutes, so that 2 days of installation time is much more than what is possible. So in this case, you have to understand that scalability is happening in minutes, elasticity is available, so you need to understand that you take advantage of those. The fourth aspect is you have to understand the basic concept that you're actually stop paying for your resources when you turn them off. So as soon as you optimize your application architecture designs, you will see the results and your savings reflect in your next month bill. So this is a continuous process of optimization and reducing your cost overall. So you have to master your trade-offs as well as make sure that you're continuously optimizing. And last but not the least is the whole automation piece. Now, cloud gives you access to scriptable infrastructure, so you have to make sure that you automate using the APIs. The basic ground rule here is if you're doing 3 times a particular thing over and over, then it is a good candidate for you to automate that process. So investing some time in automation is extremely important. So if you make these basic things inherent about your application, and if your application works in a particular way, leveraging the scalable infrastructure, both your architecture and your infrastructure works in concert to give you the scalability that you are looking for. So with that in mind, now I wanted to quickly zip through the AWS cloud or the buffet of services that AWS provides. Amazon provides regions, and each region is having multiple availability zones. Availability zones are logical data centers that don't share the same powering, cooling, flood panels, and fault lines. And we have a variety of different edge locations around the world, 18 edge locations which will edge cache static content make it closer to your customers. On the top of that infrastructure, there are a variety of infrastructure building blocks, and on the top of that platform, and also there are several higher level building blocks which do a specific task for you. There are a variety of different cross-service features available which allow you to do things like monitoring, authentication, and automation. And then there are a variety of different services available. There are a variety of different tools and IDEs and SDKs available to access these services. All the information is available on our website at aws.amazon.com. So I'm not going to spend time talking about the cloud and assume things that you know about AWS in general. So now let me quickly go into specifics of some of the lessons that we have learned, some of the things that we feel are very important to address when you are building elastic cloud architectures. So to understand, these are the basic 6 things, and this is also a part of the white paper, so please feel free to read through some of those as well. So basic concepts and basic lessons that we have learned is design for failure and nothing will fail. And I'm going to talk about in a little bit more detail about some of those examples and best practices around these basic lessons. So without any further ado, let's go into the first one. First one is design for failure and nothing fails. Now, it's very simple and very easy to understand that the basic rule of thumb is that be pessimistic when designing architectures in the cloud. Assume that things will fail, and by assuming that things will fail, always design and implement and deploy for automated recovery from failure. In particular, assume that your hardware will fail, outages will occur, assume that some disaster will strike, assume that you will be slammed with more and more expected number of requests per day someday, or per second someday. Assume that your your application was written as a software will also fail. So by being pessimistic, you end up thinking about recovery strategies during design time, and which helps in designing an overall system better. So if you realize that things fail over time and you incorporate that thinking into your architecture, building mechanisms to handle that failure before disaster strikes to deal with a scalable infrastructure, you end up creating a fault-tolerant architecture that is optimized for the cloud. Questions that you have to ask are things like, what happens if a node fails in the system? How do you recognize that failure? How do I replace that particular node? What kind of scenarios do I have to plan for? What are the single points of failure? If I have a load balancer sitting in front of an array of application servers, what if that load balancer fails? If there is a master-slave in your architecture? What if the master fails, and how does it fail over, and how the new slave is instantiated and brought in sync with the master? So these are basic things which I feel are very important, and if you make it part of if you ask these questions, it will help you build a better design. So let's see some of the basic tactics of how you can leverage some of the AWS principles, AWS services in building such a fault-tolerant application. The first one that I think is important is to use scalable fault-tolerant services as ingredients of your app. So a basic example here is that this is a typical single instance web application architecture diagram that is running in a single availability zone. You have a load balancer, you have auto scaling group, your web and app servers are running in an application instance, you have a database that is running EBS volume, that's mounted to an EBS volume is mounted to an EC2 instance, and then you are taking periodic snapshots to Amazon S3. The reason I mentioned I have CloudFront and Amazon S3 in this particular diagram is because you can isolate your static load versus your dynamic traffic and put all your JavaScript, your audio, video, all your blob files in S3 and distribute them using CloudFront, so your servers or your application server is not really loaded. So by building that kind of a design, you have you're doing a little bit more, you're putting less load on your application server. If you want to use more services, the services like Amazon SNS will help you notify if some things go wrong in your architecture, in your infrastructure. You can take off some of the load from your application by putting data in like a key value style data in Amazon SimpleDB, configuration data in SimpleDB, and you have to keep on monitoring your resources using CloudWatch. So by building this basic scalable, using some of these scalable services, you are taking load off your application server and then building a better design overall. So I believe if you're building a small application, this is one way to build a fault-tolerant application. So the second principle, which I feel that one of the things that you should do is you take periodic snapshots of your EBS volumes. And the reason I mentioned this, and the reason I feel this is a good best practice for designing for failure, is that if let's say the EC2 EBS volume failed, then you can quickly take snapshots from Amazon S3 and restore your snapshot and connect your EC2 instance back to your database, back to your EC2 instance running the application servers. There are always, snapshotting is a great feature in EBS, and it's incremental in nature. It does not store the entire blob of content all the time. It stores incrementally, and it stores only the changed bits. So if you have lots of data and your data is actually changing quite often, you are recommended to take periodic snapshots more frequently, let's say every hour. But if your data is not so changing often, then your requirement or we are recommending taking snapshots probably every day. So these are some of the things that a lot of our customers do. Another common approach for EBS volume is that they take a dedicated EBS volume which is mirrored of another EBS volume, and then snapshots happen from that dedicated EBS volume in order to not affect the performance of the master. So in the case of a master-slave combination, you are taking snapshots of slaves rather than taking snapshots of master, not affecting the performance or the I/O. So these are some of the things which I feel are really important, and take periodic snapshots overall. The other thing which I feel is important is to build an Amazon machine image of your running instance, and making sure that you are patching your Amazon machine image and not just the instance. So with your latest code as well as your latest security patches and so forth. There are two types of Amazon machine images. One is the EBS-backed Amazon machine image, which boots off from an EBS volume. And then there are S3-backed Amazon machine image, which is coming from S3, and it loads onto an EC2 instance and then boots up. For all practical purposes, I like using EBS-backed Amazon machine images because they are significantly faster, as well as it gives you some cool benefits like suspend and resume like features. So I prefer using EBS-backed Amazon machine images. So going further, now using Amazon machine images is one way. Another thing which you might have noticed is using the auto-scaling group in this particular diagram. You see the dotted line around the EC2 instance signifying that there is an auto-scaling group with minimum configuration of one instance. That means the hidden is going to use this new feature, or I would say the hidden feature of auto-scaling is maintaining minimum fleet size. So in this case, I have one. If the instance goes away, I can it will auto-scaling service will automatically detect using health checks and the load balancer, and it will take the Amazon machine image and then bring that new instance up within that particular group. So this is essentially auto-scaling for auto-recovery. We highly recommend having at least one auto-scaling group and having with a minimum setting of one if you have a very simple application. This is another great way for designing for failure. So it will automatically be resilient because you have auto-scaling group set and a launch configuration set. The other benefit of the auto-scaling group, obviously, is to horizontally scale your web tier. So based on your CPU load or your other metrics that you are monitoring using CloudWatch, you can set your threshold such that I want to automatically spawn new EC2 instances, if certain threshold is already met. So by building an auto-scaling group and managing that, it helps you build better application architectures. The other thing which I usually like to talk about is using a mirrored EBS volume in another availability zone and doing a data replication. And high availability is a continuum of things that you have to do, and it will help you build better architectures. And depending upon your recovery time objective and recovery point objective, you can decide what sort of strategies will work for you, and what needs to be more or what needs to be less, and so forth. So in this particular case, the scenario is very simple, that you are running your EBS volume or your EC2 instance is getting synchronized, replicated into another availability zone. And in this particular case, if your EC2 instance and your EBS volume dies in that availability zone, you can quickly detect that it is down or it is not responding and fail over to this new availability zone. So in this particular scenario, you are having higher fault tolerance because your volumes are spread across multiple availability zones. And availability zones are, as I mentioned earlier, are fault tolerance zones overall. They don't share the same powering, cooling, thereby reducing your probability of failure. The other thing which I like to talk about is if you feel that you need slightly more better fault tolerance as well as high availability, you can above and over these general tactics of or mirroring into a new availability zone from data replication side, you can actually do on-demand application provisioning in a different AZ. So in this scenario, you're running similar to an old scenario where you're doing synchronous replication from one availability zone to another availability zone, and then in case of, let's say, the entire fleet of Amazon EC2 instances in one availability zone dies or terminates or it fails, you can quickly bring up the same fleet or similar fleet in another availability zone and connect the dots with the load balancer as well as the EC2 instance so that you have higher fault tolerance. The basic benefit of doing this is the fact that you can you have an ability to spread your risk across multiple availability zones, and you have a better design. The higher end on that part also is like multi-AZ application deployment. So in the previous scenario, you were launching your application instances on demand. In this particular scenario, you are keeping them running all the time and spreading your EC2 footprint across multiple availability zones. So in this scenario, let's say you have a typical 3-tier web application architecture design. Now you are running your application servers, your caching servers, and your databases in a multi-AZ fashion. If your entire availability zone terminates, or you don't have access to that entire availability zone, you can quickly readjust the capacity in another availability zones that are running, and then and quickly come back to speed, or instead reduce any or not use the unhealthy availability zone and keep using the healthy availability zones. So by this, you are having additional higher availability of your application, and you're building a better design. And based on your application requirements, you can decide how much cost versus how much fault tolerance you would want to have. And as I mentioned earlier, it's really understanding the trade-offs and then mastering the trade-offs and so forth. Cost increased significantly here since the excess of compute is always provisioned, but the benefits to high availability may warrant this increase in cost. So it is extremely important to understand. So these are the basic things which I feel one can do when designing for failure, and then understanding the basic constructs of building a higher availability architecture. The second principle which I like to usually talk about is the fact that you have to build loosely coupled applications in this scenario on each other, so that if one component were to die, fail, sleep, not respond, or remain busy, or it's just slow to respond for some reason, the other components in the system are built so that they continue to work as if no failure has happened. In essence, loose coupling kind of isolates the various layers of the components of your application, so that each component interacts asynchronously with the other and treats them as black box. So this is a basic principle of a service-oriented architecture design, which you might have heard and learned in the past, but these are more relevant in the cloud speak, so to say. This reason is that if you define your service and you define your service level agreement and the way it has to interact, then it should be treated as black box, and all the services are responsible for its own scalability and its own security. So by building that better design, the looser they are coupled, the bigger they will be able to scale. One way to achieve that scalability and loose coupledness is through tight coupling. You can have tight coupling between controller A and controller B, but instead you can take advantage of the queues to have loose coupling between those controllers. So in this case, the queues act as buffers. So in case lots of requests are hitting controller A, they get buffered. And even if, let's say, the controller B dies, you can quickly resume the state after reading the messages from the queue and bring that new controller B quickly up. So it has to be more fungible. It is not only fungible, but it's also resilient to reboot and relaunches. And that brings me to the third best practice or a lesson that we have learned is the fact that elasticity has to be implemented in variety of different ways. And elasticity is fundamental property of the cloud, and lots of the cloud benefits are driven by this elasticity. Essentially, you don't need to run your application, your web application, if you are not being accessed or users are not using it. You're building applications that sleep at night. You are building applications that are following the sun and only alive during the 9 to 5 period, and while transferring traffic to other parts of the region. So you can build better architectures by building elasticity into your application. So how do you implement elasticity into your application architecture? The one thing which I really like to talk about in this particular scenario is that you have to bootstrap your EC2 instances. So by bootstrapping, what I mean, on boot up, the instance knows what it has to do, and it will do the right thing. The best way to kind of understand this is you have to have instances, when they come up, ask you a question: who am I and what is my role? And then you pass them a parameter saying you are a web role. You have to, depending upon your web role or your any other characteristic, you have to start Apache. You have to start these many things in your as processes. And you're bootstrapping it in such a way that it knows which nodes it has to connect to as well. So if it's running application server, it knows that it has to go and take the connection string and connect to the database server and so forth. So by building this dynamicity, which really helps you build better architecture designs. One thing which I like to take advantage is definitely use auto scaling and elastic load balancing. So when you spin up this new instance, you don't know where exactly it is. Now the instance does get an IP address dynamically, but it does not know what to do and how to talk to other instances in the cluster. What is its role? What happens when it goes down? So if the node is an app server, you can give them an instruction that you have to go and talk to the database server, and so that. Recognizing that in the cloud world, things are much more dynamic. Realizing that there is much more flexible model due to this on-demand provisioning nature of the cloud, and then things tend to change and does change more faster. So if you build mechanism to handle this dynamic nature and implement elasticity into your architecture, you will see that your application is cloud aware. So in this particular scenario, I recommend 3 basic things or 4 things from a software side of things. How could your software how your software should be built within the instance so that they are ready for these types of elasticity. And I feel there are 4 things that it has to be done here. First, it has to be resilient to reboots and relaunches. That means if I terminate randomly any EC2 instance, it should bring up another one and boot itself and resume the current operations. I really like Netflix pattern here, which is very popular. It's called Chaos Monkey pattern. What it does is it's a simple tool that randomly terminates EC2 instances in their fleet. So they know and they can test that if it has failed, if that instance is down, it should quickly bring up another EC2 instance and connect the dots and coalesce itself into the cluster, blend itself into the cluster. The general ground rule that I like to talk about is that if you know that your instance is running for more than 2 or 3 days, then it's the right time to maybe shut it off and create, see whether another one comes up and runs by itself without breaking any SLAs or any business SLAs overall. So making sure that it's resilient to reboot and relaunch is fundamental. Secondly, making sure that you're taking out or extracting out all the stateful components and then making your application stateless. And this is very important when building better architectures. Third, and I feel it's more important, if you can package it into an AMI, or if you can run multiple instances of your application on a single EC2 instance, or run multiple instances of that on multiple EC2 instances, then it is a good candidate for the cloud as well. So you can build that into it. And last but not the least, of course, making as loosely coupled as possible. So if you have built this basic elasticity into your architecture, you you will get better elasticity overall. So as you know, there are basic simple stacks available. And cloud allows you to build these Amazon machine images and help you, save a lot of time and increase the productivity overall, because you can share these pre-configured machine images with others, and so you don't have to do this over and over again. And this will help you in building better elastic architecture. So I have 3 different approaches in designing your Amazon machine image, and depending upon the design, depending upon your use case, and depending upon your time that you have to build architecture, you should pick and choose the right pattern. So I like to call this as 3 pizza models, and it's very easy to remember as well. The frozen pizza model, the take and bake model, and the made to order model. And let me go into a little bit more detail of each one of these. Now, for the frozen pizza model, which is basically taking everything that you have in a stack and then bundling that into an Amazon machine image, and then maintaining this inventory of Amazon machine images for you. So you can build that Amazon machine image and then share it among your team members. This is very easier to do. It's simply a right click on the console to create an Amazon machine image and so forth. So it's very easier to set up. But on the downside, if some things change, if your code changes, if your library changes, you have to recreate that Amazon machine images. So kind of it is very difficult to maintain going forward. So there are other models there. So in this particular second model, where it is more take and bake model, you're maintaining only the things that are not really changing into your Amazon machine image. So what I call the golden Amazon machine image. And all the other things which are sort of going to change, like your libraries or your code, goes out of that Amazon machine image. And then when you manage it, you are fetching them on boot time. So when your instances ask you a question, who am I? It says, okay, you are a web server, you are an application server. Now it boots up, it starts off the right, Tomcat or JBoss or whatever, and then bundles that, fetches your war file from your Java code and bundles that, starts that Tomcat processes and so forth, and then runs that on demand. By that, you are building a better elastic model overall because you are fetching on boot time. The last but not the least, the third model to build and implement elasticity is what I call the made to order model, where in this particular case, you are bundling only the bare minimum operating system that you need, and bundling a chef agent or a puppet agent onto an Amazon machine image. And this is just enough operating system, and everything else goes above, everything else goes outside the Amazon machine image. How this works is very simple, but it's difficult to maintain. It's very easier to maintain, but sort of difficult to set up in an initial way. But I highly recommend doing and maintaining this particular approach, because what you can do is you can build these recipes, you can build these cookbooks. These are basically infrastructure scripts that says, if it's an application server, install Apache. If it's a web server, install Apache. If it's an application server, install Tomcat. Contact the database server in this particular way. Connect the dots. Now you can script that whole thing into a recipe, and you run that recipe on boot time, and it will run it for you. So you are completely taking advantage of the programmable infrastructure using scripts. So this is a much more dynamic model and much more preferred model over others. But it's sort of difficult to maintain and build too. So depending upon your right strategy, depending upon your use case, I encourage you to take advantage of these tips overall. The fourth and lesson, which I feel is important to understand, is that security has to be built in every single layer. Security in the cloud is a shared responsibility, and it has to be incorporated in everything you do. And it is not an optional thing. With that in mind, I wanted to bring up some aspects about the AWS cloud. In the cloud, security is a shared responsibility. So there are several things that are infrastructure security perspectives. So in this case, anything below the hypervisor and to the concrete, it is the responsibility of Amazon Web Services to make sure that it is secure. Physical security, making sure that there are enough surveillance cameras, making sure there are enough levels of access before anybody has access to a physical control, a physical environment, making sure that right certification standards are met. ISO 27001 actually tells what to do, while SAS 70 Type 2 audit shows what we are doing and how we are doing in a different control objective ways, and there are how do we do change management and so forth. So these are all available to you on request. So you can take advantage of that. The other one is PCI DSS 2.0 validated service provider level 1 compliant. Now there are several services which are compliant, PCI compliant, so you can take advantage of credit card type workloads. And the beauty is that even though you don't have credit card workload, you still get the same security that you get with this infrastructure. The other part of the pie is that there are several security options and features available to you so that you can make the right choice, whether it is right for your application. And so things like enforcing using identity and access management policies, making sure that you're using multi-factor authentication or using VPC or using features like bucket policies when you're using S3 and using security groups and so forth. These are options that are given to you, and we routinely provide best practices guidance on how to use these types of services and features available within that environment. And last but not the least, the application security. It is responsibility of the application developer to build better architectures and encrypt data in transit, encrypt data in rest, protecting your own AWS credentials, making sure that you're rotating your AWS credentials every week or so, securing your own application by making sure that they are you can prevent SQL injection or cross-site scripting errors and so forth. So by building this, understanding this security landscape, it is extremely important that security is a shared responsibility, and using this in a particular way will make your application much more secure. So the fifth one is around making sure that because cloud gives you access to lots of resources, it's very important to understand and think in parallel, think in multi-threaded fashion, think in multi-node fashion, and build that into your architecture design. If certain things you are accessing in S3, I would recommend multi-threading your requests or multi-threading your request to SimpleDB. Likewise, if you have a particular task, decompose that job into a multiple smaller chunks, and then run those chunks in multiple nodes in parallel, or take advantage of Amazon Elastic MapReduce, which takes care of Hadoop, which uses Hadoop framework for distributing your parallel and computing the jobs in parallel, and taking advantage of Spot instances as well as Hadoop EMR Elastic MapReduce framework. You can get much more powerful model for your running your jobs. In this case, like analyzing your log files or analyzing massive amounts of data can be done using these techniques. And last one, but not the least one, is how you should take advantage of the scalable ingredients in your application and leverage different storage options. With cloud, with storage, one size does not fit all. There are different types of storage options available for different types of storage needs. Now there are, as I mentioned earlier in the diagram in the presentation, that you have to take off the load from your web server by using Amazon S3 and CloudFront combination. So you have a better application design, and you are having overall a good database distribution. Likewise, there are, this simple table will help you build, understand, and choose the right storage options to use when, and like which one is the right storage option. Like you should use Amazon RDS for your relational database lookup, database storage, but it's not ideal for simple lookups or even for blob data storage. For blob data storage, it's ideal to use Amazon S3 and CloudFront together. So use this table to understand which storage option to use when. So these are the basic best practices, basic lessons that we have learned. I highly recommend taking a look at some of the principles that we have on our architecture center. We also have our premium support with the Platinum plan, which offers architectural guidance to developers and users and customers. So highly take advantage of signing up for premium support, Platinum plan. And of course, we routinely blog about different architecture patterns that emerge from our customers in our blog. So please do sign up for our blog, and it will give you more information of how other customers are actually utilizing like Netflix and Zynga, and how they have actually scaled in AWS.
Great, thanks so much. Actually, Janesh, if you obviously give us the next steps for resources, if you could sort of say what you think one of the best next steps is for the individuals who are attending the webinar, could you just take them through that real quick?
Great. So the best thing I would start off is, of course, first sign up for AWS account if you have not already done so. Go to aws.amazon.com/architectures. This will bring up the architecture center if you want to understand more about the architecture information. And of course, there are a variety of different white papers. I would like 2 white papers if you are interested in building and designing newer architectures that are optimized for the cloud. Now, looking at this first white paper and the third white paper, which is web hosting best practices, will help you build better architectures. In the later part, in the later series of these webinars, Matt is going to cover how you can apply these lessons that we talked about in a context of a web application. Like how does things change in a web application way, what are the 2-tier, 3-tier models, and so forth. So this also is part of web application hosting design. So in this case, for the cloud architectures paper, you can go very deep into understanding the cloud, and then there are basic tactics in this gray box which help you understand that these are some of the things that you absolutely have to do. For example, a simple question that comes up all the time is, should we use private DNS of the server of the EC2 instance, or to expose and connect to the EBS, connect to the CNAMEs? I would highly recommend using Elastic IPs or using Elastic load balancers in front of the EC2 instance, which will give you, and so that it gives you not only the power to horizontally scale, but also to change your EC2 instances and quickly replace them.
So Janesh, we have a question in from Jonathan who was talking just about that. And actually, Matt, if you could field this one. Jonathan asked, how do you map your domain into the cloud? And what logic allows it to quickly map to new instances? Is it simply one Elastic IP that is constantly remapping with the load balancer to instances?
Yeah, so by domain, usually I'm assuming this is a Windows question. That's usually the operating system people refer to when they're talking about domains. Yeah, so when you run a domain inside of AWS, it's very similar to how you'd run a domain in any other environment. You obviously have to have domain controllers set up. Domain controllers themselves, as you can imagine, don't lend themselves well to cloning or spouting up alternates. When you're dealing with domain controllers, you have to launch them manually, provision them, make sure you promote them as appropriate to a primary domain controller or secondary when you set up your environment. And now when it comes to launching new instances that want to be members of those domains, that is certainly scriptable. It does require a little bit more effort than other operating systems. But what you would do is you would pass in, when launching a new instance, you'd pass in the IP address information for the primary domain controller. for the domain, and then the first thing you'd need to do on that instance is actually modify its DNS settings so it knows to look to that domain controller for domain information. And then using a PowerShell scripting combined with commands like netdom.exe, you would go ahead and actually add that machine dynamically to the domain. That will require the machine to require a reboot, and then once it's rebooted and then in place and actually joined as a full domain member, then it can, on the next pass through, it can look to confirm that it's a member and then do what other remaining scripting activities you might need to go ahead and get that machine operating properly inside the domain. And of course, if you're extending an existing domain out to the cloud, then what you could do, as opposed to setting up a domain in the cloud, you can use Active Directory federation services, which allow you to actually federate your Active Directory domain into a non-internal environment, which of course you can use to extend your domain controller out to the cloud for federation, for getting access or control. So there's a couple different approaches. One being setting up your own custom domain inside the cloud, or a read-only trust relationship with a domain in the cloud, or using ADFS or Active Domain Federation Services as a way to federate that domain into the cloud. Those are the two models that we've seen customers use most effectively.
Yeah, just to add to that point, we have a really good ADFS paper for single sign-on, which is very detailed, talking about all the different ways in which you can set up ADFS on Windows using on EC2. So please do take a look at this 32-page white paper that's on aws.amazon.com/whitepapers.
So Jinesh, we're a little light of questions right now. So again, everyone, please feel free to write in your questions. Do you have any type of quick how-to or something you could do along those lines that references some of the portions of the talk that you just gave, and actually showing them how to do that?
Sure, but let me go, and one of the typical questions that comes that was in the earlier webinars as well is that how can you use cloud to your advantage when upgrading to new versions of your application? And I think this is a very great, very important to address this, that you can take advantage of some of the dynamicity of the cloud, and you don't have to really move your code from a staging environment to a production environment and so forth, but instead you can actually create new instances that itself is your production environment, and then terminate your old production environment and use that dynamicity, or use elastic IPs to actually map and remap your EC2 instances with the newer version of the software and terminate your old EC2 instances, or use elastic load balancing that you are taking off all the older version of your instances that are running older version of your application off, and then slowly adding newer versions of your application in newer instances and connecting that to the load balancer. So by that you can use, instead of moving code from one environment to another environment, you can actually recreate that entire environment and use and instantiate cloud instances overall. That's one good best practice overall.
Hey, Jinesh, we got some questions coming in, so that's good.
Great.
You were starting to spark them right there, which is great. Hey, Matt, there's a question here from Chris. He says, do you have any tools that will lock a Windows instance so a snapshot won't catch it in the middle of a write?
Locking a Windows instance so a snapshot doesn't catch it in the middle of a write. So yeah, I'm guessing, so obviously with a Windows machine, certainly the Windows 2008 instances, they would be EBS backed. So obviously wanting to minimize the churn of what's going on in the operating system during the actual snapshotting process. There's a couple approaches there. Obviously the safest overall approach is to stop the box and then snapshot it, so that of course no writing would be occurring at that time. Unfortunately, that means the machine's offline during that period. As an alternative approach, you could look to stop several non-essential services. Obviously turn off things like Windows Update. Various things that are run as background processes to minimize the amount of churn that might be going on in the system at the time. that you might choose to call for a snapshot. Those are a couple of things. Obviously, the stop being most intrusive, but certainly safest because it brings that machine down while you do the snapshot, but certainly doesn't allow you to continue operating during that period. The secondary approach being just simply going through and looking at the services that are running and pausing them as appropriate so that you can actually reduce the likely churn to the root disk. Obviously, if it's a data drive that you're snapshotting as opposed to your root volume, with a data drive, you can use a couple of different approaches. You could actually set up a synchronization process between your primary data drive and maybe an additional data drive you attach just for a short period, synchronize those two drives, and then actually snapshot off the secondary synchronized copy as opposed to the primary data drive. That allows you to sort of detach that drive for a short period of time while you do the snapshot. That's another way to avoid that impact. But in the root volume, short of stopping the machine, you can't really guarantee that the operating system will try and write down. So pausing services is probably your best bet.
Great, thanks, Matt. Dinesh, we got a question from Jimmy who's talking about this. Are you able to scale the instances down, i.e. from an N1 large to a micro? And maybe we'll expand that and say, what are best practices for scaling instances in the cloud?
That's a great question. I will answer this in two parts. If you're using just plain Amazon EC2 instances, it will be responsibility of the developer to include that you are making sure that you are taking a 32-bit or a 64-bit Amazon machine image and then reinstantiating that onto a newer or a smaller EC2 instance. And those are very simple to do tasks on the console. But if you feel that the second part of the answer, if from the database aspects, Amazon RDS, and if you're using Amazon RDS, it does these things for you. In a simple setup, you can go to Amazon RDS tab and then instruct an EC2 modify instance call by using the command line, or use this tab on a particular already existing database and say click modify, and this will move by just simply clicking on these particular tab and then selecting the newer instance tab, and then it will do the things underneath automatically for you at a given maintenance window. So in this case, what's happening behind the scenes is it will take a snapshot of your volume, and that snapshot is going to be stored in S3. It will shut down that EC2 instance. It will bring up this new EC2 instance with the brand new MySQL running on a higher instance type or a lower instance type or smaller instance type, and then restore that snapshot back onto this newer instance. All happens during this maintenance window that you specify, or you can apply it immediately by just clicking on this checkbox. So this allows you, with one click, you can go from a 2 CPU box to a 4 CPU box and sort of vertically scale up. And just the things that we like to address from a simple EC2 setup is just make sure that you are using the right bit, 32-bit versus 64-bit, so you don't want to get, there are only certain types of EC2 instances available for certain bit range. So if you are using, make sure that you're creating the right Amazon machine image on that front. Did that answer the question? Matt, do you want to add?
Yeah, I was going to add one quick note on there. There is a feature that's not exposed inside the console, but is available through our command line APIs, where you can actually take a running instance, you can choose to stop it, and then you can change its instance type and then start it again. So, if you wanted to go from a large to a micro, you could actually stop it, change it to a micro, and start it again. And that would be something doable through the command line. That unfortunately creates an interruption in availability for that particular instance, and it would change its IP unless, of course, you're using Elastic IP. So that may not be preferred behavior. An alternative approach we've seen folks use is instead of instead of trying to stop and start, spinning up smaller instances, at night when you decide you want to shrink your fleet size, spinning up a smaller replacement instance then making sure that all your data is perhaps not on the root volume, perhaps on a data drive, and you can detach the volume and move it over to a smaller machine, or even just synchronizing across between the two. And once that synchronization is complete, shutting down the larger one and reverting all traffic to the smaller box. So you can either run them in parallel, cut over, and shut down the larger box, or you can stop, change the instance type, and then start a machine. So you can actually do that as well. Not available in the console, but through the command line.
Great, and yeah, the starting and stopping feature is only available for EBS-backed Amazon machine images. Just wanted to bring that up as well. Any other questions?
Yeah, Janesh, Kevin had a question about a slide you were on that had SimpleDB on it, and saying you were talking about how you could use SimpleDB to store instance configurations, and he was wondering for some examples of that.
Yeah, that's a great question. So I'm assuming this was, assuming this was the slide. Yeah, so this is one mechanism that a lot of customers like to do is to store their configuration data in SimpleDB. This is essentially machine configurations, connection strings, IDs that they have to connect to, other username, password, application level, data that is configuration data, and so forth. All of that goes onto SimpleDB. And then when the EC2 instance boots up, the first thing that it does is goes and queries this domain and in SimpleDB and gets all the information right off from that table. And from there, it is essentially getting all the role information that you are a web server and you have to connect this to a database server. And these are the connection strings and so forth. So all the configuration information can be stored in SimpleDB, and this can be very repetitive. You can your EC2 instances are very blank and opaque. They don't really have any keys or any other data. The things that you have to worry about is patching the keys in the right a secure way. So there are some best practices that customers have employed is to encrypt the keys before you send it to the user data parameterized feature during the run instance call. And then on boot up, you decrypt that keys, put that keys into your environment variable, and then it has access to the AWS credentials are available to all the application. And that will be used to query SimpleDB as well. So these are some of the things that customers do today. You don't have to use SimpleDB. You can use other features like server tagging, and that's available through an API and also through the console. That this is a web server, and you can tag that server. But the benefits of SimpleDB is that you can query your domain and see the current snapshot of your entire topology or your fleet size, like how many servers are currently running. Some of the customers also share or put the state of the current machine on SimpleDB so that they can get data of the current state of the fleet. Like some instances might go down or some instances are running and so forth. And they can get then a log of certain things later on if they want to, which the console will not give them because it's a current point in time, while SimpleDB is a log of data. It's a database. So these are some of the ways customers use SimpleDB for dynamic configuration.
Great. Thanks, Janesh. We're a little bit over time, but we still have quite a few people on the webinar. Matt, could you field one more question?
Sure.
If you're still, oh, there you are. Great.
I'm next.
This one deals with different regions, and this is from DSV. I'm not sure I'm pronouncing that correctly. I apologize if that's incorrect, but it says he's asking, are load balancers regional? If so, and I build two similar multi-server infrastructures in two regions, each with its own set of load balancers, would you be able to fail over from one region to the next with zero downtime?
Yeah, so this actually comes up a lot. Most folks discuss this in terms of perhaps having more geolocation-based distributed traffic. And Janesh is pulling up the classic slide of kind of the follow the sun model. So what what you can do, unfortunately, our elastic load balancers are for a specific region, which means that it will handle, a single ELB will handle, say, the U.S. East or the U.S. West or the U.K. or APAC. So it is specific to that region. Now we do not offer a global load balancing service that balances between regions, but there are companies that do that. Ultra DNS is one example of probably several different DNS providers that could give you that kind of a service, which would allow you to actually do a couple of different things. Oftentimes they provide you geolocation type load balancing, which says send me to the nearest data center. So if somebody's in California, they'd go to Northern California, but if they happen to be in Florida, they might end up in the U.S. East, right? So that's one feature of that set. The other thing it can do is also provide failover modes where it says, hey, if U.S. East is unavailable, you're not getting responses, fail me over to this other side. So it actually can have failure modes, and in fact, you can even have waiting control of some of those. We do not have a service that does geolocation-based DNS, but services that do offer do have the ability to do waiting. So there are automatic failover modes, which would enable you to have no downtime, and there are ways to change the weighting if you want to distribute people more to one data center versus the other. The trick with, of course, no downtime is how do you keep the data stores in sync across all those various locations? So if you have a U.S. East and a U.S. West footprint, keeping the actual back-end data stores, any writes you might be performing, or if you have large volumes of reads of data that changes often, how do you keep those various regions in sync? And that is a non-trivial problem, and we don't have any services to make that any easier than the problem that exists right now, with, of course, speed of light propagation of data. So you do have a challenge of keeping that in sync, but if there's ways to slowly propagate or pick subsets of data that have to be in sync across the regions, and then do that as a background process, then you could certainly get away with hitting an alternate region in case of an outage or a failure of a whole region. So that's certainly possible. We don't provide a service for geolocation load balancing at this time, so you'd have to pull that from somewhere else, but that's certainly a possibility.
Great. Well, thanks, Matt. And again, that'll wrap up today's presentation. So on behalf of Amazon Web Services and our presenters, again, thank you for joining us today to learn about the best practices of architecting in the cloud.